Hello and welcome to another video of the Hidden Quantum Champions here on the Polaris School of Quantum. As you've probably seen already from the video title, in today's video we are looking into a company called Sparrow Quantum, and let's find out together what they're actually doing and what their value proposition in the world of quantum technology is right away by starting on their website as per usual. So here we are on the website of Sparrow Quantum. It says unlocking quantum breakthroughs one photon at a time. With that, we already know probably they're in the photonic space, so they're using light. Photons are the light quanta, so the smallest portions of light, and probably this is what they are using, but still we don't know what exactly they're doing with it. Let's see if we can figure out more. So we see some chip here, which is on a printed circuit board, and that is mounted on some type of, let's say, optical fixture. I guess there's an optical table here in the background. So looks very, let's say, dramatic with the light effects also happening. Let's see if we can find out more about what this is actually doing. Here it says Sparrow Quantum is a global leader in photonic quantum chip technology, reliably delivering single photons on demand. So that means they are in the light sourcing part of the value chain. So they create single photon emission technology, so single photon emission devices. As you probably know from previous videos, these can play a role in, for example, transmitting quantum information. So you could use them to send quantum information from one chip to another, but they could also play a role in quantum communication and in encrypting using quantum technology and quantum encryption. Let's learn more about their solution and what they're targeting it towards. So it says product deterministic single photon source. Here we see it. It's called the Sparrow Core, and we will learn more about that, I guess. Then quickly taking a look here at the overview. So technology is from quantum dots to quantum leaps. We will learn more about that, I guess, soon. Then it says here About tab, where photonic quantum technology takes flight, and then there's also some information about careers. Scrolling further down, we find the news section. Dive into latest news, stay informed on Sparrow Quantum's breakthroughs, partnerships, and milestones. I'm recording this in November, almost mid of November. We see here that there's news on the 10th of November 2025. Sparrow Quantum launches Sparrow Nest, which I guess is this product here, and we will learn about that also more a little later. There's some other news here as well. So for example, October 28th, no one knew how to make a quantum computer out of deterministic emitters until now, and so on. Then it says we collaborate with fellow visionaries pushing quantum technology boundaries together. So again, in this list of let's say, collaborators here, there are a couple of names that we've seen before. So going back here, we see, for example, Quix Quantum, which has already been featured earlier in this series. We see some universities like the Ruhr-Universität Bochum in Germany or the Universität Wien, so Vienna in Austria. Copenhagen is also listed, and then the Niels Bohr Institute, which is also a very famous address here in Europe. There's also the Quantum Internet Alliance, which is also a very interesting player, which we will learn more about in a future episode that I can already tell you now. There's also the University of Copenhagen, but for example also Orca Computing, which has been featured earlier in this series. Interested in joining forces, then you can reach out to them. Then it also says is interested in our technology, reach out, we'd love to start a conversation. So you can get a quote and get in contact with them. And then down here in the address section, it says that they are based in Denmark. Let's quickly go up again and see what else we can learn here. So there is the products, and we've seen this the Sparrow Core already before. This is the single light emitter, the deterministic single photon source. So it says a leading chip for generating single photons on demand. Sparrow Core is a high performance single photon source leveraging quantum dots. So quantum dots are isolated quantum systems within a chip type of architecture. So what we know from, like, let's say silicon technology, so you can create little dots on those, which then are quantum dots, and they are basically confined systems where you can create single quantum states, and these transition of these quantum states, they are light activated, so you can create single photons with them. It says Sparrow Core is a high-performance single photon source leveraging quantum dots. It delivers best-in-class efficiency, exceptional stability, and reliable performance over extended operation and through multiple thermal cycles. It has over 50% efficiency, so this is how many photons are emitted into a Gaussian output mode. Then a distinguishability of 97%, so how identical two photons are even when emitted at very different times, and a purity of 99%, so how well the source avoids emitting multiple photons at the same time. So in more than 99% of the time, if you trigger it, it will only send a single photon, and it will be, let's say, very distinguishable. So it will be almost an identical photon to the time that you triggered it before. So more than 97% of the time at an efficiency of 50%. So more than 50% of the times that you trigger it, it actually sends a photon. That's how I understand these numbers. It says optimized for free space experimental setups. Sparrow Core enables seamless integration with photonic foundry PIC technology. Explore the architecture of Sparrow Core. So we see here the free space optical setup. Sparrow Core is designed for seamless integration into customizable free space optical setups, enabling high efficiency photon excitation and collection. Note external components for connecting to a 4K for Kelvin cryostat are required. So 4K is liquid helium temperature. Then electrical access, that's the PCB, so the printed circuit board here. This is the structure that you see. External connectors on the PCB provide straightforward voltage control, ensuring seamless electrical access to the chip to enable spectral tuning and minimize electrical noise. This acts as the foundational layer interfacing the chip with external control systems. Then we are looking at the chip level itself, right? And at the chip it says compact and modular. The 3x3 millimeter semiconductor chip streamlines quantum photonic operations, simplifies system integration, and enables seamless modular upgrades. And then it says hundreds of structures. The chip contains hundreds of structures, each featuring several quantum dots embedded in a photonic crystal waveguide. So the photonic crystal waveguide is basically then, I guess, used to steer or allow you to steer the light into some specific setup. There's a zoom in here. So structure, single photon source. With each structure within each structure are several quantum dots with unique properties. We always identify and characterize multiple quantum dots that meet the desired specifications while giving end users the flexibility to explore other alternative setups or different experimental configurations. And then it says planar advantages. A planar design enables stability, scalability, and functionality. The planar waveguide approach features the separation of in and out coupling to efficiently filter the pump laser from the emitted photons, offering precise and efficient photon management. So here we see the single photon source and the planar structure here. A closer look at the source, so features and benefits. Here we see what it actually looks like, and it starts with the quantum dot, right? Here we see the quantum dot, excitation and spatial selection. The quantum dot is excited by a pulsed laser at 80 megahertz. The unique planar design enables spatial selection of the highest performing quantum dot to produce distinguishable single photons on demand. Then here we see the collection via, I think, the waveguide. So it says collection. The photons are collected by a nanophotonic waveguide with near unity efficiency. So beta is more than 95%. And that's, I think, the absorption rate, if I'm not confusing, and directed to an out coupling diffraction grating. So here you can basically connect your system, and then you can extract those single photons that are being emitted here. It says ultra low noise environment by applying a controlled electric field. By applying a controlled electric field, we achieve an ultra low noise environment, ensuring the highest fidelity in single photon generation. Then the wavelength, this is like the uniqueness of these photons, right? How equal they are to each other. Here it says 920 to 980 nanometers wavelength. Advanced quantum dot engineering enables wavelength tuning across a range of 920 to 980 nanometer, providing flexibility for various applications. So this is, I guess, also quite precise range already. And then within, I guess, that range, it will be even more precise, the wavelength of the output photons. And it's also a telecom wavelength. So for telecom applications, including 1550 nanometers, we provide comprehensive application notes with guidance on setup, optimization, and integration to streamline implementation and reduce development time. Then there's some information here on the Sparrow core that we saw before. So the fact sheet: excitation is neutral excitation, wavelength 933 nanometers. Lifetime of this transition is 300 picoseconds. So the state that is decaying and generating this photon is 300 picoseconds. And then, there's also some more information here that we've seen up before. And there are also some Q&As down here and a way to get a quote. Now there's also the Sparrow nest. We've seen that in the news down before. So this is this big box here. It says plug and play deterministic single photon source. Deploy single photons on demand at the touch of a button. So before, what we saw was the chip, right? And this is going into optical setups. So this is going into your university lab. This product here is a single photon source on demand at the touch of a button. So this is a fully integrated setup. Everything that you would have in the lab, that you need to actually drive those quantum dots that is not mentioned on, or that has been mentioned in the text on the other side, is basically integrated here into a reliable out of the box functioning thing. And we will probably also learn a little bit more if we scroll down where this can actually be applied. Otherwise, we might want to check out again this news article that we saw before. So, deploy single photons on demand at the touch of a button. Sparrow Nest is a fully integrated rack-mounted single photon generator solution powered by Sparrow Core, which is the product we saw before. It offers industry-grade computer control sensors and auto alignment for consistent, high-quality photon output at the push of the button. So it includes the laser, optical module, electrical module, the Sparrow Core, and a cryostat. So the 4 Kelvin, the liquid helium temperature that is required to do this experimentation. Optimized for quantum computing, quantum communication, QKD and networking, and quantum optics teams that want a plug-and-play system for deterministic single photon generation. And there we have it. So this is a component that can be used for quantum computing with deterministic single photon sources. That's the news article that we saw before, but also for quantum communication, and here especially the QKD, so the quantum key distribution part of it in the networking. And then, of course, for quantum optics teams that want to use this as an output in their lab. Now, let's quickly look into the single components. So there's the laser, which is a high-performance pulsed resonant excitation laser, is required to drive Sparrow Core at 80 plus minus 0.5 megahertz. That's what we saw before on the core, on the Sparrow core part, right? It supports lower rates via an external pulse picker, so below 80 megahertz with dedicated optical in and out. There's an optical module in there, so precision free space optics with integrated sensors, camera, and motorized mechanics for stable photon extraction and fiber coupling, single photon output on PM fiber, and then the fiber is specified here. So it's basically all the optics that is in there can automatically be aligned, and yeah, there's also cameras and sensors in there which make it that easy and out of the box experience, I guess. There's an electrical module, industrial grade computer and control electronics handle automated startup, alignment and calibration and continuous monitoring for closed loop thermal optical stability, because don't forget there's also a cryostat in there that has to cool down everything for Kelvin, right? It runs as an unattended service and interacts through a served web app or automated with an API, so an application interface. And then there's the Sparrow core that we saw before. Here it also explains now how it is built. It's an indium arsenide based quantum dot chip, providing world-class single photon matrix. That's what we saw before with this wavelength range mentioned before. And then finally there's the cryostat, and I think we've also talked about cryostats. We've actually talked about lasers before in this series, about optical components. We had suppliers for optical components. We've also talked about the cryostats before. So here it says we recommend a compact cryostat to house the Sparrow core. Compressors placed in an adjacent rack for vibration suppression, supporting stable long-run operation. So usually these compressors, they also make a little bit of noise, and you might not want to sit next to the compressor because it generates this possibly annoying noise if you hear that all day long. Okay, quick further look down on the page, right? Built for seamless deployment in labs and supercomputing centers. Sparrow Nest is built for advanced labs and HPC, so high performance compute sites, and ships as a fully self-contained system in a standard 19-inch rack. It runs on standard power and integrates all subsystems in rack for quick deployment and reliable day-to-day operation. And here we see basically the standard rack size that they put it into, and some frequently asked questions down here, as well as some pictures of the design. So designed for quantum researchers and innovators, engineered as a fully automated turnkey solution, Sparrow Nest delivers single photons by optical fibers, streamlining integration into other setups. And here we see what the setup look like. So basically it's a big black box, and I hope it's not a black box after what we talked about, because now we know what is inside, which is the Sparrow core and also some other components. Now let's quickly also take a look at the companies. I don't want to go into the insights tab now, but I really like the fact that, okay, they explain also a bit more the technology here, which is the underlying technology of the Sparrow core, I guess. So the quantum dots themselves. There's also something about customer stories and publications. So here we see different customers like the University of Warsaw and Vienna who have been using that already. But I want to check now quickly on the company part of things as well, because we always do that. So it says, building on a legacy of quantum breakthroughs in Copenhagen, Sparrow Quantum, deeply rooted in decades of groundbreaking research. Sparrow Quantum is a spin-out from a powerhouse of innovation, Professor Peter Lodal's research group. I hope I didn't pronounce that incorrectly, at the Niels Bohr Institute. We are building on over 25 years of groundbreaking research, further enhanced by nearly a decade of engineering efforts. We specialize in advancing light-matter interfaces, the critical components required to scale optical quantum technologies. At the heart of our innovation is our on-chip deterministic single-photon source, so the Sparrow core that we saw before, right? A technology that sets industry benchmarks and is trusted by quantum technology leaders worldwide. Empowering our partners and customers with cutting-edge solutions, Sparrow Quantum is turning the immense potential of quantum technology into real-world innovation and impact. And I can actually imagine that like this single photon source technology with the quantum key distribution capabilities is indeed something that has quite a lot of interest now, because even though quantum computers are still very much in a development phase, so you see new news every day, there are already quite some establishments happening in the world of quantum encryption and quantum key distribution. So I can imagine that there's a lot of interest now from this industry to learn more about that. Here it says, building on the Niels Bohr legacy in Copenhagen. This photo is pretty famous, I guess, with all the big quantum hats on there. Niels Bohr himself as well. Sparrow Quantum, and then I guess this is the team behind the company. Sparrow Quantum carries forward the pioneering spirit of the Niels Bohr Institute in Copenhagen. With its primary lab space located in the institute's basement, Sparrow remains deeply connected to its roots while advancing cutting-edge quantum photonic technologies. Here it says there's more than 40 people working there right now. And then finally down here, the mission is lighting the way for quantum breakthroughs. Our mission is to harness the power of light to unlock scalable, practical quantum solutions that address real-world challenges and create transformative opportunities across industries. We achieve this by pioneering the development and commercialization of key quantum photonic building blocks, laying the groundwork for the next generation of quantum computing, secure communication, and the quantum internet. We collaborate with the following visionaries, and that's what we've seen already before. And then down here is the usual things like address and social media links. With that, we are already at the end of today's video. If you liked it, please make sure to give it a thumbs up. If you don't want to miss out on the next one, you also know what you have to do. If not, watch one of the other videos where I explain it at the very end of it. And with that, I'm looking forward to see you in the next one. As always, make sure to stay hydrated. Until then, bye-bye.